Welcome to Spring LIB.
So we have a thin uniform rod. Bent into a square. And we'll say side length equals A. We have a total mass of capital M. And due to the parallel axis theorem, so this is the moment of inertia of a parallel axis equals the moment of inertia about an axis that goes through the center of mass plus the mass times d squared, where d is the distance between the axis going through the center of mass and the parallel axis through the parallel axis that we're trying to find. So essentially, this IP is going to be helpful in the sense that this signifies essentially that we can choose whatever this axis we can choose whatever we'd like this axis to be, and then we simply need to know the moments of inertia about an axis through the center of mass. So here we can say that m is going to be equal to m over 4, and this is going to be equal to mass of each side. So we can say that moment of inertia of each side about an axis passing through the center of the side and perpendicular to the length, this is going to be equal to ma squared over 12. Because again, ma squared over 12, this is simply the formula for the moment of inertia of a slender rod. Essentially, the moment of inertia of a slender rod, however, the axis is passing through the center of the side of the square. So essentially, through the center of the side, through the rod, essentially. So this again will be capital Ma squared over 48, because after we substitute m equals capital M over 4, this becomes Ma squared over 48. And we can also define and say that so if this is through center of side, we can write another moment of inertia. This is going to be Ig. And what this means is that this is the moment of inertia of each side about an axis through the center of the square and perpendicular to the plane of the square. So here, this is actually going to be ma squared over 48. This is essentially Ig plus ma squared over 32, over 16. So we found the moment of inertia through the center of a side or through the center of a rod, and then we used the parallel axis theorem in order to find the moment of inertia of each side about an axis that is through the center of the square and perpendicular to the plane of the square. This is going to give us ma squared over 12. And at this point, we can say that the moment of inertia through the center of the square, so square, is simply just going to be equal to 4i, because we have 4 sides. So we have 4 times ma squared over 12. And this is going to be ma squared over 3. So this will be the moment of inertia of the square that we're trying to find. So again, we first found the moment of inertia about an axis through the center of a rod or through the center of a side. Then we use the parallel axis theorem to find the moment of inertia of each side about an axis through the center of the square and perpendicular to the square of the plane of the square. So that's why here d equals a over 2, because we're trying to, d would be from the side to the center of the square, so a over 2. And then we multiply this number, this I, by 4 in order to find the moment of inertia through the center of the square perpendicular to the square's plane. So this will be your answer. And that is the end of the solution. Thank you for watching.